Alright, so we're going to be finishing off the graphs here, and this time I want to look at the ratios. Now, if you haven't gone in to do the actual exponential exercises, this part of the video might go a little bit fast for you. So if you're not picking it up quick, or if you don't think you will, my suggestion would be to go watch the actual videos on how to find the exponentials first, in detail, and then come back and watch this as a summary for yourself. So, as we did trying to find the rule for any pattern that we're not sure what it is, we're going to find a first difference. And here, my first difference between 18 and 6 is 12. Between 54 and 18 is 36. And between 162 and 54, the difference is 108. So you can see here the first difference is definitely not constant. And if I am not sure what it is, I would go on to check the second differences. And the difference here is 24, and the difference here is 72. So I notice that the second differences are not constant either. So it tells me that's not a quadratic. I've confirmed that one. And I know it's not linear because it's not a constant first difference. So what I need to check next is what we call the ratio of the first differences. So I'm going to look at trying to figure out if there's something that timeses between all these numbers. Like instead of adding by 3 from 5 to 8 to 11 to 14, is there something that I can times 6 by to get to 18 and then times 18 by to get to 54? And how we do that is we're going to take the first differences, I'm going to take the second one and put it on top of the first one as a fraction. So 36 over 12. That's the same as 36 divided by 12, and the answer we get for this is going to be 3. And I'll check with another one as well. So I always want to take this first difference below, lower in the table, and put it on top of the one above it. So it's going to be 108 over 36. And when I do 108 divided by 36, I get 3 again. So what I'm finding here is that the ratio of the first differences is constant. And that tells me that I'm going to have an exponential equation. So again, if you haven't figured out what exponential is yet, it might be a good idea to stop this and go watch the other video. And we'll see how we go here. So with exponentials, this ratio is always going to tell me the base. So my general rule is going to be y is equal to the base to the power of x, and then there's some sort of question mark term that's either a plus, a minus, a times, or a divide. And we've got to figure out what that question mark term is. So I'm going to write out this table with a little bit of space in the middle. So I have p 1, 2, 3, and 4. Now I'm going to use my base, which in this case I found was 3, so that constant first difference, that's also equal to our base. So I'm going to have 3 to the power of x in the middle of the table. Leave myself a little room, and put in the rest of the numbers over here for m. So I have 6, 18, 54, and 162. And now I'm going to use some substitution here. So in this case, p, if you remember, is going to be our x, so I could probably say 3 to the power of p if you want. And if p is 1, what is this going to equal? So that's 3 to the power of p, and in this case, 3 to the power of 1. If you put that in your calculator, you get 3. 3 to the power of 2, because 2 is the next value, I'm going to substitute it in, so that's now 3 to the power of 2. That's 3 times 3, which is 9. 3 to the power of 3 is going to be 27. And 3 to the power of 4 is equal to 81. So again, in each of these cases, looking at what the p-value is, or the x-value here, putting it into my base as a power, so 3 to the power of whatever, and checking to see what I get. Now, this is where I've got to figure out the question mark. 3 to the power of the p is the start for us, but what do we need to times, divide, add, or subtract to get from this column over to what we actually want for m? So let's take a look at the first one. I got 3, and I need to get to 6. So one way I could do that is by timesing by 2. Let's see if that works. If I times by 2, 3 times 2 gets me 6. Check it in the next row. 9 times 2 also gets me 18. 27 times 2 will get us 54. And 81 times 2 will get us 162, so it works. In contrast, if you had thought like, well, 3 to 6, I could go plus 3. So 3 plus 3 is 6, that one works. 9 plus 3, that doesn't work. Doesn't get us to 18, that only gets us to 12. So in this case, it is definitely times by 2, times by 2, times by 2, and times by 2. So my question mark becomes times by 2. So, going back up to write out my rule, I know this would be y is equal to 3 to the power of x, and we've found that we need a times by 2 to make the rule work. And then I'm going to put it into context like we've done for the other ones. Y is m, x is p, and then times by 2. And that gets me my rule for the exponential.